Hey guys, good to see y'all. I hope you're well. Uh, I'm using my computer camcorder, so it's not going to be the best video possible, but that's the way it goes. Now, somewhere on your computer, your Chromebook, at least on mine, it's on the right-hand side, is a place where you can uh, type in questions. It's a chat thing, and as you have questions as I go along, just type them in there, and then periodically I'll try to remember to come back up here and look and see what y'all have written and try to address those. Yeah, I see Chloe saying that your science class starts in 5 minutes. Yeah, I understand this is going to interfere. And Chloe, uh, you can leave at any point, and this thing will automatically record to this YouTube channel of mine. So you probably need to subscribe to this YouTube channel. I'm not sure, but you can come back to it through the link I sent. So it's no problem. And I understand some people aren't going to be there, but I wanted to take some time to review some of the trick, because this is one of the hard topics really in math too. So I'm going to start. Well, first of all, I wanted to show you all my classroom. Y'all, I'm going to move this thing up a little bit closer, and get back with me if there are ways I can improve this, because I'd like to do this again. But like I said, this is all brand new to me in terms of the live streaming. I'm actually going to start doing it at my church too. What I've been doing with my sermons is I've been recording them, and then editing them, uploading them, which is kind of a hassle. But this live streaming, I hope, will be good. Anyhow, I hope y'all have some paper and pencil. And like I said, if you miss something here, it's going to put a recording of this back on my YouTube channel, and you can catch it there. But the first thing I want to begin with is the Pythagorean theorem, which I need my glasses again. For most of you guys, let's see, someone else has left a message. It says, someone forgot me 245. Hey, I don't know who that is, but glad to see you. All right, the Pythagorean theorem. Let's take a right triangle. And we know it's right because of that little deal there. And let's say this side is 6 kilometers long. We're looking for that length, and the hypotenuse is 10 kilometers. Now, one way you can always tell it's a hypotenuse, there are two ways. It's always the one across from the right angle. Secondly, it's always going to be the longest side also. Now, the Pythagorean theorem is that the hypotenuse squared is equal to the sum of each leg squared and then added together. The way we normally write it is we use C. C squared is equal to A squared plus B squared. Now, if someone could chat, can you see this board okay through the screen? If someone could write down whether you can see it all right, type it down. I would appreciate that, because I have a little picture here of what the camera is showing, but it may not be exactly what you can see. Now, when you do the Pythagorean theorem, let's see, Chloe says, yes, it's fine. All right, thanks, Chloe. I appreciate that. When you do the Pythagorean theorem, always put the hypotenuse on the left side. But always put the C squared on the left side. So in this case, and let me change colors again. We're going to say, all right, we got 10 centimeters, and the kilometers squared is equal to 6 squared plus x squared. Now, it does not matter which order those fall in, but what does matter is that you've got the hypotenuse on the left side. So now we're going to solve for x. So we've got 100 here is equal to 36 plus x squared. We'll subtract 36 from both sides. You get 64 is equal to x squared. Now, as you can probably guess, we're now going to take the square root of both sides, and we have 8 is equal to x. Now, you probably remember that with square roots, you have a positive and a negative, but we're not interested in negative dimensions. So the length of that side would be 8 units long. And I see that Forget Me 245 says, yeah, you can see it. Good. I'm glad. All right, so that's the Pythagorean theorem. You've had that before, I know, at some point. Let's go on now to the special right triangles. And these are typically hard for students. You've got 2 types. You've got the 45, 45, 90. And you've got the 30, 60, 90. And there's just no slick way to do this. You've just got to memorize it. So with the 45, 45, 90, now you don't need to know that you don't have to write down 45 because that's all that could be. It's 90 and 45 from 180. It's got to be 45, 45, 90. What is important, though, is to realize those 2 lengths are always going to be identical. They're going to be congruent because it's an isosceles triangle. So, for instance, if this is 5 units long, that one's going to have to be 5 units long. And the hypotenuse is always whatever that number is times the square root of 2. That's the part you've got to memorize. Now, with the 30, 60, 90, again, it can be laid out any old way, but I happen to have drawn this one this way. This is 30. That's 60. Now, the key side here is the side across from the 30. We'll call that 5. That's where you got to start. So this is side 5, and the side across from the 60 is going to be that number times the square root of 3. And the hypotenuse will be that number times the number 2, not the square root of 2. Now, over here, it's the square root of 2. There, it's just the number 2. That you've just got to, on plain paper, write it down until you've got it memorized. All right, so let's do a couple of problems like so. All right, let's go back here. Yeah, I didn't draw that too well, but okie dokie. So you've got this set up. Well, we know it's a 45, 45, 90 because that can only be 45. So you don't actually have to write it down as long as you know what kind of triangle it is. We know because this is isosceles, if this side is 3 square roots of 6, this side's got to be 3 square roots of 6 as well. And the hypotenuse is going to be whatever that is. In this case, it's 3 square roots of 6 times the square root of 2. And don't let the fact that that's a radical mess you up. It's, whatever that side is, it can be any old crazy thing. It's always going to be times the square root of 2. So in this case, we can quickly multiply 6 times 2, and we get 12. And then we should recognize that 12 can break down into 3 times 4. So that's the square root of 4 times the square root of 3. Square root of 4 is the number 2. So the final answer then for x would be 6 square roots of 6. Now, I purposely am giving you some that are a little bit more difficult just because we had the easier ones the other day. Okay, let's now go to a 30, 60, 90. And incidentally, if you're wondering how long this is going to take, I'm thinking about 10 more minutes is what I'm going to plan on doing. So I should have mentioned that to begin with. All right, so let's go to the next sheet. Let's do a 30, 60, 90, okay? All right, I'm going to do 2 of those. Okay, so we got this. We know this has got to be 30. That's all it can be. And the side across from the 30 is always the important side, but we don't have that. What do we have? Well, we have the hypotenuse. Okay, well, we need to remember that the side across from the 30, in this case it's y, times the number 2 always gives you the hypotenuse. So in other words, y times 2 would have gotten us that 6. So divide both sides by 2. Side y must be 3. Okay, so if that's 3 and that's 6, then the side across from the 60 is that number times the square root of 3. Now, I realize at this point in your learning, this seems complicated, and I do understand that. And that's why you just got to memorize these relationships. But once you do, then it's not that big a deal. All right, now this is the only time it gets a little bit hard with these 3069s. So let's do another one here. And I realize I'm going kind of fast, and you're probably trying to take notes real quickly, so I'll try to slow down a little bit. Okay, in this situation, we're given the side across from the 60. Okay, well, how do you get that number? Well, it's always the side across from the 30, in this case, n, times the square root of 3. So what you want to do is you say, okay, well, we know that n times the square root of 3, whatever n is, managed to get us that number 6. Well, n is times the square root of 3, so let's divide both sides by the square root of 3. That cancels out, and so we have n is equal to 6 over the square root of 3. But you probably remember, you can't have a radical in the denominator. So we're going to multiply top and bottom. We're rationalizing the denominator. That's what it's called. We multiply here, we multiply there. And so we have 6 square roots of 3. Square root of 3 times the square root of 3 is the square root of 9, which is the number 3. And then you should notice that 6 can divide by 3. So you have 2 square roots of 3. All right, and that took us a while to just find out that side. All right, so that side's 2 square roots of 3. Well, what's the hypotenuse going to be then? Well, it's always this side times the number 2. So 2 square roots of 3 times 2 is going to give you 4 square roots of 3. Now, what I would suggest you do is get the right answers and practice that. That's as hard as it gets. If you can do that one without making a mistake, you're fine. That's as hard as it will get. Okay, now let's go on to the trig ratios, which you picked up last week. And let's see here. We'll call this angle A, B, C. And we'll call this 5, 3, and 4. Now, I'm going to put over here that the sine, let's say the sine of angle A is the opposite over the hypotenuse. The cosine of angle A is the, not opposite, adjacent over hypotenuse. And the sine relationship, man, I am messing up here. Y'all are used to that. I know. Tangent of angle A is opposite over adjacent. Okie dokie. So right now we're just dealing with angle A. We could be doing it with angle B, but we're choosing angle A. In terms of angle A, would you agree this is the opposite side? I hope you'll agree. This is the hypotenuse, and this is the adjacent side. As I said in the notes last week or the video, this too is adjacent. It forms that angle, but that's already got a name called the hypotenuse. So we don't count that one. It's always the other one that's adjacent. So the sine of angle A then would be opposite over hypotenuse, 3/5. The cosine of this angle would be the adjacent over the hypotenuse. So that would be 4. And then the tangent of this would be opposite over adjacent. Okie dokie. Now, let's practice finding some of these sides. And the other video for this week is going to help you find angles. I may do one of those just to give you a heads up. So we'll call this number 1. All right, we're trying to find the length of what in fact is the opposite side of this angle. We know the hypotenuse. So then you have to think, all right, what trig function deals with opposite and hypotenuse? Okay, that's sine. So we're going to find the sine of 75 degrees is going to be equal to the opposite over the hypotenuse. Now to get x by itself, we multiply both sides by 8. And we'll have it. All right, let me get my calculator. Now, hopefully you have loaded in to your phone that app that says Calculate 84. I don't know if you can see it too well, but it's on mine. It's this one right here. It's pink. It says Calculate 84. Now, here's what it looks like when you open it up. And as I've mentioned a couple times now, anytime you're using trigonometry, you've got to change the mode. So you'll go here. The default is always radian, but you want to move it over to degree to do trig. Well, there we go. So move it over to where it says degree, and then hit enter. Now, with this particular phone calculator, it'll stay there until you come out of the app, and then you'll have to go in there again. All right, so let's go back to where we were. I want to multiply 8 times sine of 75. So I go 8. I happen to know I don't need to use the times sign. It automatically does it. So I'm going to go sine 75 and hit enter. And so that means that length x is approximately equal to 7.7 units. Now let's do a couple more because I know that this is all new to me. Let's see, what else did I come up with? All right, let's do all right, now in relation to this angle 28 degrees, again, we've got an opposite and a hypotenuse. So it's going to be sine, opposite over hypotenuse. And remember that little mnemonic device. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Toa, opposite over adjacent. If you can remember toa, you should get it. All right, so we know it's going to be a sine function because it's opposite over hypotenuse. So we're going to do sine of 28 is equal to the opposite over the hypotenuse. But the hypotenuse happens to be the x. So we've got to get the x out of the denominator. We do that by multiplying both sides by x. So on the left, we have x times sine 28 is equal to the number 6. Well, what do we do now? Well, since we've multiplied here, we're going to divide both sides by sine 28. That cancels out. And so in our calculator, we're going to do 6 divided by the sine of 28 degrees. Now, I have not closed out my calculator, so the mode is already in the right place. It's in degree mode. So all I have to do is type in 6 divided by sine 28 and hit enter. And that's approximately 12.8. All right. Now I'm going to do one that it will be new for you this week. Just to give you a heads up on this thing. And then we'll be done. Let's see. Okay. Here, we've got a right triangle. We're given two sides. We're trying to find that angle. So anytime you're going to find an angle, this is when you're going to use inverse trigonometry. And first of all, let's decide which trig function we need to use the inverse of. Well, we've got an opposite and an adjacent. Sorry, opposite, adjacent, all right, that's tangent. So we're going to say the tangent of, let's call that angle X, is going to be opposite over adjacent. Now, in your calculator, above the word tangent, you'll see tangent to the -1, and it's in blue. So to solve for this angle, all you're going to do actually is find the inverse tangent of 18 over 25. So let's do that together. Again, this is what's new this week, but it's if you get the trig functions in your head, it's no big deal. So we're going to go, because I need to get the tangent to the -1, I need to go second. It's the light blue tangent. All right, and it's inverse tangent. I type in 18 divided by 25, and I hit enter. And so that means that this angle is approximately 37.8 degrees. And so last week we were finding sides. This week we're going to continue finding sides and find angles. But when you're finding angles, you only use inverse trig. All right, I think that's enough. Thank you for tuning in. Let me know and remind if this was useful to you. If it is, I plan to hopefully can do this maybe once a week from here on out. Also, there's some news coming in terms of the way your grades are going to be. We have a meeting a little bit later today, which I'm going to get the details, but the little bit I know of it, it looks like you're going to get to choose between two things. Either just get a pass for the second semester, or if you've got a good GPA and you're concerned about it, you can take the actual grade, which depending on what you do could help. So, but that's all I know, and I could be wrong. I have been once or twice in my life. But anyhow, see you guys. Thanks for joining me. Bye-bye.